Alright, this tutorial, there'll actually be several variations on this one, on how to bake textures to game assets. Anytime you're dealing with assets that you'll create for a game, your number one concern is speed. And this is an interactive tool, and so you need this to play back to the player very quickly. So in the world of Maya, what that means is low polygon count. So we need to build objects that have relatively few polygons. So that's our first concern. But the second concern is the aesthetics of the objects. We're trying to create interactive, immersive environments, whether they're photoreal or cartoony or what, but you want to be able to create a certain look and feel of the space. So the way that you start with the idea that your object has to be low polygon, so the game engine can calculate them quickly and move through things. But you also want to make it look good. So the look good part comes from textures. And certainly you can just hand paint textures in Photoshop and put those onto your objects. That's a good start. But how do you get more complicated levels of detail like bump mapping or displacement or ambient occlusion? How do you get those into objects? So there's going to be a series of tutorials that shows you how to do that through various functions of baking textures, which is a way of pre-calculating the complexity of a surface or the ambient occlusion or what have you into an actual texture and putting that on the object. So I'm going to start here with this one real quick. Start with this modified box I've created, just polygon modeling. I inserted and beveled some of these different faces, you can see here. And I created some polygon spheres and duplicated them and placed them around the sides of this box. And combined them all into one object. Right? This is my complex box for whatever reason. Where, I don't know, it's going to be a crate, or this would be in some sci-fi level off to the side, contains who knows what. And I have turned on in display and heads up display. I've turned on poly count. So it's telling me how many faces this object has to create it. So I have over 6,000, 6,500 faces. And you also have to remember that every game engine is going to use triangles instead of faces. They're simple and quicker to redraw. So we have over 12,000 triangles here for this object. And in this tutorial, I'm going to show you how to take this surface information and bake that into a map onto this cube that has 12 triangles. So obviously you can have a lot more cubes in your world like this with 12 triangles than you can at 12,000. So, and the process for doing this is going to be baking a normal map, but as we bake that information, we're also going to transfer it from the complex object, which is our source, onto a target, which is our simple little cube here. So if you'd like to follow along and actually do this step by step, you might want to pause the tutorial now and go ahead and create a cube that has some surface variation. You know, if you want to create little studs that look like rivets and place them along the surface. I started with a cube that was 10 units by 10 units by 10 units and extruded in these faces and added some of these details. And just for simplicity's sake, I made sure that all of it fit within the that 10 unit space. Okay. All right. So go ahead and create one of those, and then after that, you can, when you start creating it, you can actually duplicate one and have another cube that is, again, 10 units by 10 units by 10 units. So they're exactly the same size as far as their outer bounding dimensions. All right. So if you want to, you can pause right now, build those into your scene, and then come back. All right. So I've got my two objects in the in layers here, and I've changed my window settings to rendering. my submenu. So, and I've selected the simple cube, just the simple six-sided cube. And I'm going to go up to lighting and shading and transfer maps. And this is a function of baking. Now, baking again is pre-calculating lighting or reflections or ambient occlusion or any of these things and into an image that you would then put onto your object and you would insert into a game engine. So they're already pre-calculated. It doesn't have to render shadows. They've already been rendered onto the object or anything like that. And for our purpose here, we're going to do normal mapping. Normal mapping is, in essence, displacement mapping or bump mapping on steroids, or if you can think about it, is video game displacement mapping. Instead of using a white and black material to define how a surface is embossed in its little fine details, it's going to use a color image so that every little pixel, even though the surface might be flat, the pixel itself might be saying I'm facing a little bit to the left, right, up, down, whatever. And so you'll get lighting characteristics on there. So when we bake this, you'll get a sense of what this looks like. I'm going to go up and reset this. I've been doing little examples here. I want to make sure I do this the same as we go along. And so the first part we're going to start is, very top here is target mesh. And if you had the GameCube or the simple cube selected, it already loaded that as your target mesh. This is, so your target is your low polygon mesh, and you can see it says simple cube. It's going to use the UV map that I have there, just it's the only one that was created, just the default one. And display, instead of just the mesh, I want it to show us the envelope. And the envelope is kind of a duplicate of this cube. What we're trying to do is make sure that this fits snugly over this object, the complex one. In fact, you can see here I can change the size of this just so I make sure everything fits inside that box. You don't have to do that all the time, but you'll get better results if everything fits within here. You can even right click and modify the UVs for this envelope shape and adjust certain points to make sure everything fit inside of it, in case you were doing an organic, like a head model or something. So we've changed this, we'll leave it at the UV, display is envelope, and we made it just a 1.5% bigger, just to make sure everything's inside the envelope, the high res is. Let me change that back. Click out of there. Alright, and now I need to select my source mesh, which is our more complicated shape, and I need to load that. So I just click on it and say add selected. So complex thingy shape 1. So this is a source that's going to be, its surface normals are going to be projected onto this target as it fits inside this envelope. Okay, so we have those parameters set. And we need to now, so we load the target, load the source, and now we need to tell it what kind of map we're going to bake and transfer. So we're going to do a normal map. And we'll just do a TIFF file down below. Sorry, just off my screen, TIFF. And you can change this to whatever. Let's save this to source images, class, let's see, no, let's just do cube 7, I'll do that, and normal. And make sure again this is TIFF, so I'm going to save this in the source images, cube 7, normal. These are the defaults we find. These are fine. The Maya output, so we want to figure out how big the image is going to be. So I'll do 1024. That's a little big maybe for this, 512 by 512. But just so we get decent quality, so you can see in the example I've made this a little bit larger. World space just has to deal with how it's going to calculate how this is coming out of the surface. Sampling quality, we'll go with the high quality. Texture seams, if there's any seams in the texture, it's a way of repeating that last pixel on the edge so that you don't get any dark lines along an edge of a... In fact, I have used, let's use 5 just to cover it. all that's the same. Now you can render, I think I have my render settings actually with, let's do Maya software. You can also render with Mental Ray. There's one little thing you have to turn on in one of the long list of Mental Ray's preferences, the translation between Maya and Mental Ray. But for this purpose it won't matter. So we'll go ahead and, we just don't need to talk to the Mental Ray, and under Advanced Options, this has to do with how is it going to search that envelope and figure out how to project everything on there. So we'll just tell it to search inside the envelope only. Here would be closest, so it's trying to figure out one way or the other. Some problems can arise with this. This is a relatively simple shape, but inside envelope only. And search depth, I'll just put that at 100%. Delete the envelope. This again, kind of a duplicated box that it's created. You could turn that off and delete it later. And then we want surface normals. This is really important. Make sure to get the surface normals will be calculated into this. All right. So I think we have all of those. We've got our target. We've got our source. We're going to do a normal map. We're saving it in a certain place. We've defined its size, the quality, and told it how the envelope should function. So we'll go ahead and just bake this out. And you'll see here it's going through this. It'll take just a minute or two to pound this out. Sip on my tea here for a second while I wait for that. And so while this is working, again, we're doing the normal maps. You can bake the diffuse shading of one object to the other, or the ambient occlusion, or lots of different things. So some of those might be easier when we deal with just the straight baking itself. But the transfer maps, if you're going to do normal mapping, this is the only way really to do this. So at least the simplest way to do it. Okay. Let's just minimize that for now. And let's open up the Hypershade here. What's happened is Maya has created a new material, turned it into a Lambert as a default. I'm going to actually change it to a blend so I can see the shading of it a little bit better. And if I zoom in here, you can see the hints of this, again, like bump mapping. And it created a bump map node here. I'm going to come back to that in a second. And it created this image that, in fact, let's just try it. It could be a little big here. You get the feel. So it created this image here, this purpley, red, green, blue thing. And what this is doing is it's telling the pixels, instead of the surface, which way it is facing at a pixel level, not as a surface level. And we'll translate that onto the object you'll see here in a second. So again, combination of kind of bump map and displacement mapping. Again, I just think of it as bump mapping on steroids. And just a lot nicer, you'll see here in a second. So that's what that image looks like. The other thing I should mention, let me go back to that, is under the bump node, normally this would say bump. This always says bump. But we need to tell it to calculate differently. So tangent space normals is, again, it has to do the directionality of the pixel on the surface. We'll get out of that. Now to view this in Maya, let's see how well this works. Here's our simple cube. It won't show it as a default. First of all, we would have to be in texture mode, which is 6 on the keyboard. So 4 is wireframe, 5 shaded, 6 with texture. And we need to change the rendering, the viewport. Instead of default quality rendering, we need high quality rendering. Right? And the one thing that drives me crazy, at least in my 8.5, is there's a bug in the software that doesn't seem to realize and use the layers over here. So I'm just going to go up under Show, Isolate Selected, and tell it only to look at the object I have selected. Right? So here is, in fact, maybe what I should do is, this is a way of comparison. Okay. So here are our two objects. Turn that crazy grid off. Alright, so from a distance, these really, you cannot tell the difference. Okay? They look very similar to each other in places. Right? Difference being that this is 12,000 and this one is 12 triangles. Right? So if I zoom in close, you can see that the normal map here, this is totally flat. There is no actual extruding of the surface. Right? So that's thing number one. In fact, I'm going to go to my material here and make it a little shinier. Let's make it a little lighter. Just to see how the highlights roll across that surface. See the way that shine kind of comes across there? Hits these edges. See how nice that is? It almost looks like it's beveled. A couple things you should know about this is we're comparing the two. Again, there's no actual physical change of the surface. Just the illusion of that. And one thing here is I modeled these indentations here. I did it with a slight beveling. I didn't just extrude straight in. I extruded it and then scaled it down a little bit smaller so that this is more of a scalloped bevel as opposed to this straight indentation, which I did here. You can see I basically extruded that straight back here. And if you look at the difference, here's this scalloped bevel here on the edges. It shows up better as opposed to just straight back. It's going to do these rounded elements of geometry much better, obviously, than just straight back because of the way it views the angle and sees it. So when you do any of these extrusions, I would change the angle up a little bit instead of doing something straight back like that. Make sure you bevel or round it a little bit. Okay, I could have done it straight back and actually just beveled this edge around the surface to get a detail that would be more helpful. Okay, so that is, let's get that out of there. So remember, you have to turn this high quality rendering on so that it will show normal maps in the editor view. And this will go right into any game engine, almost any game engine. And again, you could use something like this to create normal maps for brick or cobblestone pathways or all manner of things and get more detail, more bang for your buck instead of doing just normal bump mapping. So, hope that was helpful.